Hello, guys. I'm here to talk, to present to you this lightning talk about applying Tekton to ingest data in a RAG model. Here is our agenda for this talk. So I'm planning to talk a bit of myself, a quick introduction. Then I'm planning to tell you the story about how we are doing this inside Red Hat. Then I plan to show to you the pipeline we are creating, and then the triggers we have to trigger this pipeline. So some information about me. My real name is João Pedro, but everybody calls me JP. I'm 30 years old. I'm from Brazil. I'm an information engineer, which is a mix between computer, electronic, and telecommunication engineer. And I'm currently working as a software engineer at Red Hat. A fun fact about me, I was here last year talking about image segmentation, and here I am again. So let's start our talk with the model. If you were here last year, you probably heard about Conflux, which is a new way to ship software program, software container. And by the way, there are some talks about Conflux this year too. And Red Hat is taking the lead into this initiative. And if you are a software engineer, you've probably been in a situation, or you probably will be in a situation that you are trying to introduce some new technology into your work. And introduce new things, it's always tough times, because people are used to the old technology, and you are trying to introduce something new, and there's always a lot of fuss. And at this moment, you need to give time to your users, to our users, so they can understand how the technology works. And at this moment, the support job is key to keep the business running. And who are the better set of people that can provide support for our users? Well, it's the people who are involved into this project, into Conflux project. And we need to find the perfect balance between providing support and keeping developing new features. To find this balance is really hard. But let's remember we are entering in the AI age, and the hype of the moment is generative AI. We are hearing a lot of stories about ChatGPT, Gemini, that can summarize documents, that can be trained to understand a new set of knowledge. And what we are trying to do here is to use AI, this kind of technology, to create a model and consume it in and create a support chatbot, a level 1 support chatbot. So this way, we use this chatbot to answer basic questions, and if it's a complex question, we let our developers, our Conflux contributor, to answer this question. So level 1 support is the idea. And okay, and how is Tekton applied to this? Well, what we have is a live application that's plugged in our instant app communication. We are using Slack, but it could be Discord or maybe Matrix. And what we want is our users go to the chat, ask questions, and our live application answer it back. But we don't want to show our users the training process. For our users, it should be something like, hey, I'm going here, I'm typing my question, the chatbot goes, search for the answer is here, okay. But we don't want to show the training process. If we have to train something, we don't want our users to notice this. And the thing is, we are using Tekton to handle this process. So Tekton is applied decoupled for our application in a way that Tekton goes, fetch the documents, train the documents, the new large language model, save it in a database, and it's ready to be consumed again for our live application. Then I want to show you the pipeline we are using. So this is the pipeline. It's the general idea we are trying to implement. Great part of it is already implemented, and it's a Tekton pipeline. So it's basically a YAML file where we describe which parameters we want as input and what are the tasks we are trying to execute and the steps of these tasks. So the first step is the get step, which we download all the tools and information that we required. For Conflux chatbot, we are using two sources of information, which is the public documentation, which is available for everyone, and an internal documentation, which is a Git repository. And it's not available for everyone because there's a lot of things that common users don't need to know, but is really useful for the bot and for internal users. So we download the sources and information and the training software we are using. And the output of this stage is the documentation in the Tekton local environment. Then we go to the chunk stage, which we are trying to clean the document. So as I said, we are using a website with the public documentation and an internal Git repository. So we don't need a lot of files, so we need to clean. So we don't need JavaScript files, we don't need CSS files, we don't need anything that is not Markdown or the HTML we are using. Then we chunk the text, and the chunk is basically have all the text we need, and we need to slice into smaller pieces. And basically, we define a width, and with this width, we create our pieces of chunks. And we can use a big chunk, the whole document, but in fact, what we want is smaller pieces in a way to provide more context or a better scoped slice to feed our model. Currently, we are using, I think, 500, the width of the chunk. Then we define an overlap region, which is sometimes the context of one piece is probably depend of the other piece. So we define an overlap region between them. And the input of this stage is the output of the last stage. So it's the documents. And the output here is the local path for the chunked text. Then we move to the training stage, which I think is the most important stage here, because it's where we train the model, it's where we feed up with the documents we downloaded. And here, what we are trying to do is to grab a language model. Right now, we are using Llama. And what we want is to attach Conflux knowledge to this model. And this training model, usually, when I train it locally, it took about 1 hour to train, but this time can vary according to your computational resources. And the output here is the local path for the language model, which is the embeddings. And after we generate the language model, we want to save it because we want our live application to consume this model. So we move to the store stage where we pick up this language model and we save it in our Postgres. And we are using the PG vector feature to store the embeddings because this language model is a vector at the end. And the output of this stage is the language model of the last stage. Whoa, I didn't expect this problem. Cool. Okay, I showed to you how to use Tekton in the chatbot, what was the idea behind, the general idea of the pipeline, but how do we trigger this pipeline to create a new training? So we are working basically with 3 ways to trigger this pipeline. And what we need to do to trigger a Tekton pipeline is create a pipeline run object. In simple words, is a request with the data we need to provide to Tekton to work. And we can do this manually, which is really not the case we want to do, mainly because the idea of the pipeline is to automate things and not depend on one person to go there and hit a button. Usually manually is only for testing and things are working, but what we really want is to watch our sources of documentation, and for every change we have there, we trigger this pipeline again to generate a new model and be able and allow the live services we have to consume this document. And if you notice, all this pipeline, it's kind of generic. So you can apply every source of document at the beginning as input, and it will generate a new training that will allow another live application to consume and answer questions about documentation. And which allow us to work with when a new bot arrives. So we can use this pipeline to train other models, to train other documentations, and users can use it in a very generic way. And that's how we are applying Tekton to feed up a reg model. Any questions? So we were asking about, in the training process, if we are generating the embeddings of this language model, right? Yeah. 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 That's the idea. We grab a language model, and we are trying to attach our new model, generating the embeddings of this new documentation. Sorry, I don't get it. So when you have like a documentation, right? Let's say you have 20 documents. Yeah. Mm-hmm. Mm-hmm. So the question is if we create the index when something changes, or we just apply for the new change, right? We are not in that stage yet. So for every change, a small comma in the document, we are generating everything again. Mm-hmm. So your question about, I answer you outside. But thank you guys, and here's my LinkedIn.